Hello again, everyone. So in the previous video, we had some interesting error that Python was not allowing us to delete an object or delete something from a dictionary during the in a runtime. So we could not change the size of the dictionary in terms of the keys or the values. When we attempted to implement the function, which was this one here, like that, it was not liking that. It did not like that we were operating on a graph in multiple ways, trying to after we construct it, we could not loop because the iteration will be shorter and it will give Python some confusing signals. So Python was kind of screaming at us. So this is the error, and I wanted to make sure that we actually resolve this together, because you're likely to have something similar to that as well. I poked around and I found out that the only way to actually make this problem to work is to change the Python dictionary here to a list, like that, to treat it as a list. And if you run this, you should not have any issues. Believe it or not, it was so simple. So let me run this. So this is now my dictionary in full. I run it here one more time. And now this is the new version of the function here. I'm going to run it one more time. And now if I remove I'm going to call this function, and remember that this function is not yet inside the class. We made sure that we took it outside the class because inside the class was causing us some problems. So we managed to get it to work outside the class. Let me run it one more time with the new addition here, converting the Python dictionary into a list. So I'm going to run this one more time, and then I'm going to remove here. So it's been removed. Now I would like to see if the Python has if the dictionary here has the F, and clearly here it doesn't have it in a key. How many we have here? Right now we only have 5 keys, and the keys don't include the node F, and the values also don't include the node F. Now the problem is how to embed this back on into the graph, into the dictionary object, into the network object, into the network class. So I just moved it here, and the only thing we need to do now is to remove this graph because we already have it as part of the instance variables right here, so we can utilize this guy, and everything seems to be in order. So it's an exact copy from what we've done here below here, like that. So we have 2 different for loops, one that loops over the dictionary keys as a list, and one loops over the dictionary values, and those guys don't get impacted because the graph size, because the dictionary size did not change. The only issue was actually removing the keys versus the actual values. So I basically ended up putting it back here again. So we have now a remove function. I'm going to run this cell, and I'm going to run this dictionary one more time. So now we know that the dictionary here, let me create a cell. And if I run this dictionary here, I'll find that I have the F node has been returned, because now I ran a fresh copy of the original dictionary, and this is the nasty error here. So I'm going to use this dictionary object to populate a network object from the class right here, and it takes 3 different parameters: the name and a type and the dictionary. So I'm gonna do this. Now what do I need? Let me create another cell here in between, and I'm going to invoke the info function. As you can see how useful this function is. And I'm going to print it and see how many nodes we have. It says that we have 6 nodes, and the name of the graph is a collaboration graph and undirected and so on. Now, what happens if I run this guy here? Do you think we're gonna have an issue similar to this one? We don't know, but let's give it a try. Now, remove the node is going to try to remove this node from the dictionary object that is part of the network class instance variable right here. So that's why we're not passing this graph, we're not passing the graph to the remove function because we're already invoking it on the network object. So I'm going to do that. And it seems like we did not have any issues. Now let me run the info function, as you can see. So before, let me do this so you see for sure. Let me run it one more time and do this here. Now you see we have 5 nodes versus 6 nodes. Okay, so how do I know that I have actually gotten rid of the this annoying error here? Okay, so it's really easy. What I'm gonna do, I'm just gonna grab the dictionary object from the class using the get graph like that, and this is supposed to give me the graph, so the dictionary object as a graph, and I'm gonna print it, and let's see if we find the F. Do we see any F here? I don't see any F's. Why don't we do the same thing, run the same function again on a different node? So which one do you think we should do? C is available in the key and a value. That's a good candidate. Let's give it a try. So I'm gonna do that. And now we have a new dictionary object here. So I'm going to make sure. I'm gonna run it one more time. And do we see any C objects here? We don't see any C objects. So let's also make sure that we print the graph, print some info on the graph as well, like that. And it indeed removed, and as you can see, we keep getting less numbers. So let me also do something really nice, because remove here returns the actual dictionary. This is the graph underscore dictionary like that. We gotta be sure that it's actually returning the dictionary. All right, what am I gonna do with this? I'm going to import network X as NX, and I'm going to create a graph object from network X, nx.graph, nx, like that. And I'm going to pass this dictionary here, and this is gonna be my NX graph. So we know that this belongs to NX, network X. And why am I doing this? Because I want to make sure that I visualize it in a way. Okay, network X, I misspelled it. Now I wanna be sure that if I draw this network here, because this graph, this network object that we're creating cannot be visualized. So we're basically leaning on network X to give us the beautiful visualization. And I gotten rid of C, and I also gotten rid of F. So I should not see the F or C in both in the new graph. So I'm going to do it with labels because I want to see if C or F are there or not, true, like that. And I want the color, the node color, to be red, like that. Okay, well, because network X, the object itself, NX, is the object, and not the graph is the object. So the draw function does not belong to the actual graph object. It belongs to the to network X module. So if I run it one more time and another time, I should not have with labels here. That should give me more labels. And clearly here, I don't see any nodes labeled as F or labeled as C. Okay, why don't we run it one more time? And maybe if we get rid of E here, let's see if this is gonna entirely destroy it or not. So I'm gonna do E, I apologize, like that. And now I'm going to pass this dictionary again to a network X object, and I'm going to visualize it. And as you can see, we've gotten rid of E here. This is really fantastic. And I really like the way that we're debugging this kind of nicely by embedding really nice functions inside the class. The info function here, as you can see, is a really useful function. All right, so now we learned how to remove objects from, nodes from the graph. What do we need to do if we need to remove an edge? Well, you can actually specify an edge. And you can say, I want to remove this edge instead of removing the node entirely, because the node could actually be connected to some other nodes, and I don't want to remove it. I just want to remove the node. So let me do this. I'm gonna run this cell one more time, and I am going to visualize a network X like that. So now I'm going to visualize. So I created a new network X object from this dictionary here, like that. Now I would like to draw it. So we can decide together which node that we want to delete, which edge we would like to delete. As you can see, if I delete node A here, then I lost all these guys. I lost the connection with D and B and C. So what if I don't want to do that? What if I just want to remove the edge between A and C? Suppose another good example. Suppose if I remove D, then I destroyed the relationship between B and D and B and A. Suppose I don't want to collaborate anymore with A. D doesn't want to collaborate anymore with A. So, but D wants to collaborate with B. So removing D here will entirely destroy the relationship that it has with B. And the best way to handle this is to actually say, I want to remove the edge between D and A. Is that something possible? Well, let's try to do it. Let's talk about it first. So what we need to do is to remove an edge like that. So because we are inside the class, we always pass the self. And since we want to remove an edge, and this edge is actually identified by two ends, it is identified by the left and the right. So we can refer to these as left and right, or we can say source and destination. Left and right makes sense for the time being. It doesn't really matter. Or X and Y, but I really don't like X and Y's because they are just been overdone. So let's try to see if we can erase an object, an edge here in the graph. How do we do this? Well, in this case, we would like to iterate over. Well, clearly, if we are doing the left, then we have to remove it from the keys. Okay, this is going to be the source, and this is going to be the destination. So if we remove it from here, we have to also remove that specific node from the relationship. So suppose I want to delete D and A. D an A. So this is what I want. This is really what I want. So if I decide that I want to delete this, how do I do that? Okay, I don't know if we have taken too long on this video, but what we can do for the time being is to see if we can iterate for key and value in what is the graph object, like that. And we might run into the same problem of converting the dictionary into a list if we use the items function, I mean. Okay, so if we are supposed to delete the left, so the left has to be a key, and the right must be in the value of that key. And if it's not, then we're not going to delete it. So let's start first with the key. We're going to ask if the key equals left, equals left, because that's equality. Okay, if this is in the key, and because we gotta be sure that both the source and the destination, the left and right, belong to the same object, to the same person, in the same, they have to be in the same value of the same key. They cannot be expanded across multiple records, because I know if I want to delete DNA, I still want to be sure that I delete these guys from each other, not to delete the actual nodes. So let me just make sure that I do this, and right must also be in the value, must be in the value here. If this is the case, I want to delete the edge. How do I do that? I want to pop the key like that, and that's right, but I have to also use this pop against the dictionary. I could also use the delete function as well, but maybe pop will do as well. But I also want to make sure that I want to delete, I want to append. Maybe I need to delete, I need to delete the right from the value first, and I want to delete the key from the dictionary after. I think this is okay, and let's try to return the actual graph after that, the actual dictionary. If we get an error, we get an error. But I think this is decent. Okay, now let's try to remove an edge. But before we remove an edge, we have to run the class here to see if we got any errors or not. We did not. Okay, and I'm going to run this graph again, dictionary, so I have the entire thing in memory. And then I'm gonna create some cells here, and I will create a network object of our network. This is my network object. So I'm gonna use what we used in the previous example. And now I have my collaborator graph, and what I want to do now is to remove edge like that. And my edge that I want to remove is DA. I want to remove this guy, DA. So the first, the left one is D, and the right one is A. And this is gonna give me a graph dictionary like that. And if all goes well, we're not going to have any errors. Let's try. The same issue that we had. So let me tell you, maybe what we need to do is to convert this into a list like that. And then we run it one more time. We'll run it one more time. Well, actually what we need to do, we just gonna run this on keys versus keys key value. We're just gonna run it on the keys. So we're gonna iterate over the keys. And we are going to convert the keys into a list like that. And now what are we gonna do? We're gonna ask if, instead of saying the value now, we're gonna get that value indirectly by saying the value here is what we are going to get from the dictionary embracing the left node. This is going to give me the value. So if that right node is in here, then remove the value, remove the right from the value, and pop the key. We could also, instead of maybe using pop, I would like to try to use the delete. Well, let me try this one more time. Let's try that, and if this doesn't work, we are going to try the pop. Okay. Right now we have not deleted the key yet. We only removed and we converted these keys into a list. So let's see. Hopefully this will do it. So I'm gonna run the class one more time. And now we have the graph object, the graph data structure here. And we are going to construct a network object. And now let's try to delete that node here between D and A. Okay, here's what we did not do right. When we started to work with the keys only, we had keys and values. We don't have values anymore. What we need to do is to make sure that we actually use the value, which is essentially what the key here is going to return. The key or the left, because now if they go in here, they will be identical, so it doesn't really matter, but makes sense now to pass the key to the dictionary. And we gotten rid of the keyword value here that was causing us issues, because there's no such a variable here that we named as value, because we used to have key value like that, and when we invoke the items. But now we want to get rid of the runtime issue, so we gotten rid of the value. Okay, let me run this one more time. Now we want to work with a new graph object, and let's try to remove this edge and see. Hopefully we done things right. It seems okay. So here's what we need to do. We are going to visualize the graph. Okay, so let's create a new graph object from the new dictionary. Well, the new dictionary here should not have DA, should not have this, so let's just print it. It does not have DA. It still have a D, still have an A, but it does not have that connection DA. It does not. But did we do things right? Let's take a look, because this is how the old graph looked like. Okay, and I'm not going to destroy it. I will just leave it like that. And I already have this in memory, but let me instead of doing this, let's just create let's create a new object from the new dictionary, a new network X graph object. So that would be new like that, because I don't want to override this guy. I still want to see the old one, and I still want to look at the new one. So here is my new object. Now I want to draw it. So I'm going to draw it after this guy here. So I'm going to take a copy of here. Now what do I need to do? I need to draw the new one versus the old one. So let me see. Okay. Where's DA? Do we have DA? Okay, it seems like we still have DA. Why is that? Well, if this guy does not have DA here, so we should be okay. It seems like we have a really identical graph. But if you notice here, A and D is still here. So we deleted D and A, right? But we did not delete A and D. That's the issue here. We deleted D and A, but we did not delete A and D. That's because, again, this is an undirected, so what we need to do is to also to try the other way around. That's why I'm thinking source and destination is okay, but that's fine. Now I'm going to do the same thing, but I'm going to do the reverse order. So instead of doing, now I'm going to do now I'm going to take a look at this graph from a point of view A to D versus D to A. So this is going to be right, and this is going to be left. So every right will be left, and every left will be right. And hopefully this is not going to cause us problems. Hopefully we're not going to get this terrible runtime error. So we're going to run this one more time, like that. And we'll run this one more time. We'll run this one more time, and we do this. And let's take a look. Do we have any connection between A and D? It's either common. Do we have? So C is connected to B. B is connected. Well, B is connected to A, and B is connected to D. It doesn't seem to have anything related to A and D. So let's make sure that we use this dictionary here to create a graph object. And since we already imported that once, we don't need to import it every time. And then we run this guy. And this is the old one. This is the old graph. Just a minute. Well, okay. Let me run this one more time. I want to make sure that I construct a NetworkX object with the graph right here. Okay, this is the original network. All right, now I want to construct, and I'm gonna cut this. So I just want to make sure that I don't have anything distracting. So now I have, now let me create a new object like that. So now I'm going to use the new dictionary after I delete it, like that. And this new dictionary is going to initialize a new network object. And I would like to visualize it. And I see some very good news here. As you can see, the relationship between D and A is destroyed. Those guys have been divorced, and as you can see, D is no longer talking to A anymore. However, the most important thing here is that D still exists, and A still exists. So what we needed to do, again, we wanted to make sure that we get rid of this annoying error. So every time you want to iterate over the keys, you might want to convert them into a list, especially if you're going to be removing data, and the dictionary size is going to change in the runtime. So this is the highlight of our lecture today, learning how to cope with this. And oops, just have to gonna run this as a markup. Okay, so the gain today is to learn how to work with the dictionary size changing in the real time, in runtime, as you can see, and being able to work with the graph to be able to keep the nodes that we need to work with, but at the same time being able to get rid of all the edges that we don't want. And this is a really great example. I really like this example here because it shows me that I still have B, D and A, the ones that we decided that we did not want. We wanted D and A to be divorced. Now, as you can see, D even has the Python Network X has actually moved B from here, as it was connected in a closer way, to the other side because it just the Spring layout, which is essentially the default layout, makes things far from each other based on if they don't have a relationship, so they make it readable. So this is really good. The gain for today is to learn how to we added a new function to remove nodes. We added a new function to remove edges. And we were able to do it in the deep way versus the shallow way. As you can see, if we did it here one time alone, you do it from left to right, you do it from D to A, but if A has a relationship to D, you have not removed it, so you have to do it from both ways. Unless you're working with a directed graph, and then you still need the other direction. If DA is important to you, but D to A is not important, now the graph, if the graph type is directed, and we have not covered that yet. If the graph type is directed, then you only do half of this. So depending on the type of the graph, you might want to add or remove things. But for the time being, this is an undirected graph, which directions are not important. Therefore, we needed both to get rid of the extra edges that we did not want or did not need to see. Okay, well, I hope this is clear enough. I hope we shed some light on this annoying error here, removing and iterating over a dictionary in runtime and trying to change it by removing or updating or adding or deleting clearly throws a runtime error here. And we knew how to work with that by converting the keys, by iterating over the keys as a list as opposed to a dictionary key. So anyways, this is really good, and I hope this is clear, not confusing. If it is confusing, feel free to write me some comment or shoot me an email if you have my email address. And as always, thanks for watching.